Okay, so you're playing darts. Let's get a dartboard. I give you 3 darts, and I ask you to shoot your darts at the dartboard. So here's number 1. Ooh, wow, that might have hit somebody. Here's number 2, and here's number 3. Wow, bullseye! Congratulations. That's really good. That's really good. So then I get the 3 darts and I hand it to your neighbor, and she throws them. And here we go. 1, 2, 3. Those are her 3 shots. What am I going to think of you? Well, if I want to work with one of you guys in order to get you up to that dart master range, I'm probably not going to pick you, my friend. You are very inconsistent. I would probably pick your neighbor, this one. Why? Because she is very consistent. Now, she may not be able to see very well. I may have to put some glasses or some contact lenses because she's nowhere close to the target, but at least I can work with her consistency. You are all over the place. In chemistry, we're going to deal with accuracy and precision. Keeping this in mind, let's deal with these terms. What does it mean to be precise in a measurement? Precision refers to the ability to make several measurements with the same result or close to the same results. Okay, you're using a thermometer to measure the temperature of an individual, and I get 97.4, 97.3, 97.5 degrees Fahrenheit. Okay, what does that mean? That means that that thermometer is pretty precise. It's off by zero point 0.1. That's not bad for digital thermometers. Okay, what does it mean for it to be precise? It's like this: you shoot an arrow the same way, and you get really all 3 arrows, just like those 3 darts, very, very close to one another. You may not hit the bullseye, but you get them very, very close to one another. That is precision. That is precision. Accuracy refers to how, well, how accurate is it? How close is that measurement to the true value? Okay, so let's go back to 97.3, 97.4, 97.5. Okay, you average it together, it gets to be 97.4 degrees Fahrenheit. Now, that's your instrument. I get an instrument out which is really, really accurate, and it comes out to be, the temperature comes out to be 98.621 degrees Fahrenheit. What does that mean? That means that the instrument I gave you, the one that you used, is precise, but it's not very accurate. For it to have been accurate, it would have needed to have been like this: 98.7, 98.6, 98.5, which averages out to be 98.6. At that point, the instrument would be precise because it's very consistent and accurate. Can you be accurate but not precise? Yes, yes. So what if you get 97.3, 98.6, and I'm just eyeballing this, 99.7, and the average comes out to be 98.6. Hey, you got it. Bullseye. Okay, the average is correct. But were you precise? No. Your measurements were all over the place. Your measurement was all over the place. You were accurate in that your 3 measurements averaged out to be the right answer, but you were precise in that the measurements were not closely packed together. So you can shoot 5 arrows at a target and hit 1 bullseye. The rest were all over the place. You were accurate, but you were not very precise. What is your goal? Your goal in chemistry is to be precise and accurate. Precise and accurate. If you can't be both, I'd rather for you to be precise. I'd rather for you to be precise, because if you're accurate but you're not precise, then guess what I call you? I call you lucky. The goal is for you to get the right answer consistently. You understand? Consistently. If given a string in measurements and the exact answer, how can you determine if you are accurate or precise? Ask yourself the following questions. Were the numbers closely packed together? If it's yes, then you were precise. If it's no, then you were not precise. And folks, I'm not going to try to trick you. They will be, if it's to the tenths, there'll be a tenth off. If the measurement is to the hundredths, there'll be a hundredths off. I'm going to make sure that it's obvious that they are very closely packed together. Do all the numbers average out to be the right answer? If it's yes, it's accurate. If it's no, it's not. So let's do a couple of examples. You measure the mass of a block of iron to be 2.5 grams, 2.6 grams, 2.7 grams. Using a very precise and accurate scale, the block was certified to be 2.6 grams. Were your measurements accurate? First of all, I want you to notice that they were measured to the tenths range, okay? Were they closely packed together? Yes, they're just one off on either side. Yes, closely packed together, so it's going to be precise. Now, let's average these numbers, 2.5, 2.6. Okay, it doesn't take a math genius to come up with the conclusion that the average is 2.6. The answer is 2.6. It's accurate as well. It's that easy. You measure the temperature of a liquid to be 23 degrees, then 26, then 30, then 37. Okay? Notice it's to the ones place. Are you about one off in the ones place? No, no, no. You're all over the place. All over the place. The very precise instrument measures it to be 29 degrees. Let's try averaging these numbers. Average them. Go. Average them. Average them. Average. I'm waiting for you to average. Take out your calculators. Average, please. Average, average, average. Okay. So it averages out to be 29 degrees, which is the right answer. Yay! You're not a complete goofball. Were you precise? No. Were you accurate? Yes. Am I going to have any confidence in that instrument? No. Am I going to have any confidence in you? No. No. I would rather for you to be precisely wrong than to be accurately imprecise. Does that make any sense? All right.